All right, friends, green tea consumption was associated with a reduced risk of breast cancer with a statistically significant test for trend, P less than 1 in 1,000. Okay, saying that in a kind of a more statistical way, we can say that the chance we got what we got, which was reduced breast cancer data, at least as low as we did, assuming that green tea is not the contributing factor, is less than 1 in 1,000. Now, here is a look at that same graph again. There is the null sampling distribution. Non-green tea drinkers' breast cancer rates. Because we're assuming that green tea has nothing to do with lowering breast cancer. But then the study comes back with this very interesting p-value that's way down here. Now, it could be way down there for two reasons. The first is that maybe green tea literally has no effect whatsoever on breast cancer rates, and we just happened to get lowered breast cancer data. Maybe. But the chance of that happening, as we just saw, is less than 1 in 1,000. So there's a very small chance that if green tea is not the associated factor with the breast cancer lowering, it's a very small chance that we would have gotten the data we got. So if it wasn't random chance, then what is it? Then there's another distribution that stands for green tea drinkers' breast cancer rates. And it's going to be to the left of the non-green tea drinkers' breast cancer rates because they're going to have a lowered incidence of breast cancer. And what's more likely if you observe the red asterisk? Is it more likely that you're on the blue curve? Or is it more likely than you're on the yellow curve? We'll just compare the heights. You're more likely to be on the yellow curve because the probability is higher than on the blue curve. So I want to recap that again. When you get done a hypothesis test, this is all you know. You know your null sampling distribution and you know where your data landed and what its p-value is. That p-value could have been that extreme for two reasons. First of all, maybe it belongs on this curve and we just got really, really, really lucky or unlucky. But the p-value is so tiny, it's hard to believe that it belongs on that curve. It's easier to believe it belongs on that curve. And that, my friends, is the interpretation of small p-values, which generally speaking are less than 5% in research. When you get a small p-value, it means you're in the outlier position on the null distribution. So it's too hard to believe that you belong here on the null, which means it's easier to believe you belong on the research. Okay, that's enough nuts and bolts. Let's go give the first homework a shot.